Hi everybody, greetings from Denmark. If you can hear this though, it means that the live feed hasn't worked out. But don't worry, because I would have been saying the same things that I'm going to be saying here. Punk 2 is way better than Punk 1 was. A lot of work's gone into it. It's available now on GitHub. So the obvious question, or where to start, would be to answer what is Punk? Well, I'd like to start by saying what's not different in Punk. Punk uses Scala, which compiles down to bytecode. It runs on the JVM. The web application deploys as a normal WAR file, just like you used to, and can deploy it into any servlet container like Jetty or Tomcat. Now, Scala can also use any of the Java libraries that you're familiar with. The static resources, that is the .html files, the JavaScript files, the style sheets, they can all be deployed in the normal WAR package structure and will be delivered in the normal way. The Punk application, you configure it just using the normal web.xml. It uses a filter to bind to your URLs that you want to create. So what's different in Punk then? Well, I've tried to use the best of the Scala language. There's so many amazing constructs in the language that help you to develop in better ways or more concise ways. For example, the pattern matching in Scala is very powerful and amazing. The match case statement lets you match on object type or pattern, and this pattern matching is used to actually define your URLs to create your endpoints for your services. In terms of the interface for dealing with the HTTP request and response, it's more functional. Rather than having a servlet type interface where the request and the response are passed as references and you can manipulate the request and response through those references, Punk takes a more functional approach. As Scala is a functional language, the request is the input to the function and the response from your function is the actual HTTP response that goes back to the browser. Punk also uses Scala's built-in XML support. You can actually put XML as literal code, much like you'd put string literals. So Punk's templating capabilities haven't been built. They're using Scala's native inherent capabilities. Scala performs very well, and everything's very easy to test even without starting up a container to do so. So let's start with a Hello World example. Here I've created an object. Now, object in Scala means that it's not a class. You don't have to later create a new instance of this definition. It means it uses the singleton pattern. There's only one of these things created. So object means that I'm going to create a new object called myServer, which extends server. The server class has been provided by Punk. Then I have a defined method called services. And services equals a partial function. It's a partial function because the other part of the function is being abstracted away. That other part matches on the request object that Punk has created by marshalling all the request information that's coming through the traditional servlet API. So what happens here is that I'm saying I want to match on the case where I'm getting an HTTP GET where the top level path is /hello. And I'm going to respond to that request by passing back the string hello world. You can see here that even though it's a string, Punk does an implicit conversion. It knows it has to pass back an actual HTTP response object, but Punk is doing the work of saying, well, if it's a string, I actually know how to convert a string to a HTTP response. So it's doing that for you in this case. And then just to emphasize again that the input is the request, which we're matching against, and in Scala, the last statement within a block of code, in this case just the literal hello world, is the response from the function. So let's make things a little more complicated. Now I've got two elements to my path, a /hello/Tim. That's what I want to match on now. And of course, I can say something more specific like, hello Timothy. That's great, except it's not going to scale well. I'd have to create a line of code for every name of person who's going to use my system. So I can start to do some really amazing things. And this is all down to Scala. I haven't built code specifically to do this trick. It's built into the language. Rather than putting a literal there in my match case get, I can put a variable name. In this case, I've called it name. And then I can use that name in the response. So what Scala is doing here is it's actually saying, well, the pattern matches. I have two elements in my path, and the first one does match that literal hello. And I do have a second element in my path. Whatever that value is, Scala is actually assigning the value to the variable name within that one case statement. And the variable is then ready to use in the response. And it's all type safe. Scala actually knows that those path elements are strings, and so name is a string. It's amazing that now I have one line of code that parses my path, marshals my data into variables, and is ready to provide output, the HTTP response. So what else can we do with these case statements? How would we match against the root path? Well, we just put a get with no path elements in it. What about something like getting a person with an ID, where ID is a variable that gets populated with the second element of the path? What about something more complicated like some kind of taxonomy? So you can see here we could do a match on HTTP get where the path is place, then bind the next three portions of the path to a country, a state, a town. Then you can see an example of a URL that might match that pattern, and those variables will be populated. So what about where there's no fixed length to the path? What if you're actually presenting some kind of directory structure or some other list of things on a URL? So in Scala, underscore means match anything, and when it's got a star after it, it means match any sequence of any length. I can use the @ notation to say I want to name this list of things. So this case statement is going to match on an HTTP get where the first element is sum and then any number of things, and will be assigned to that numbers variable.